Hey guys, it's Rena, and today we're going to be doing lessons 2.13b and 2.14, and we have a few special guests, but our first one is...
Hi, I'm Chelsea. I'm in AP Calc if you haven't watched any of my other videos, but yeah, let's get going.
Alright, I'll be starting off with some notes, so let's get to it. Okay, so first, what restrictions are there with the arguments of these logs? So, first off, we know that inside the parentheses of a log, it can't be a negative number. So, like right here, for instance, x minus 8 must be greater than 0. And if you add 8 to both sides, x must be greater than 8. Now, if we look at this side, 3x plus 4 must be greater than 0. If we take 4 from both sides, 3x must be greater than negative 4. And if you divide by 3 on both sides, x must be greater than negative 4/3. So now you see that you have two inequalities. And really in this case, the only inequality that would matter is that x is greater than 8. Because if you plug in a number that's greater than negative 4/3 into this example right here, you're going to end up with a negative number in the log. So not in all cases, because if you go above 8, which is still greater than negative 4/3, it'll be fine. But let's say you do 1, which is greater than negative 4/3, but not greater than 8. You're going to get negative 7 right here. So that's why you have to look at the greater one, or one that includes both inequalities, if that makes sense. Like if you're looking at a line, if you're looking at your x values, okay, let's say this is your coordinate plane, and it has to be greater than negative 4/3, like bigger than that, and it has to be greater than 8, you're gonna have to, like, they intersect at 8 technically, because anything greater than 8 is still greater than negative 4/3. So x greater than 8 is your answer. And that was just us solving and comparing the intersections. Alright, now we have this example, log base 2 of 2x plus 6 is greater than 3. So again, we're going to go through the same process. We know that whatever is inside the parentheses cannot be a negative number. So 2x plus 6 must be greater than 0. Or in other words, 2x must be greater than negative 6. If we divide both sides by 2, x must be greater than negative 6 over 2, which is just negative 3. Okay, so that's one of our inequalities. Now we can look at the whole equation as a whole. So 2 to the power of 3 is less than 2x plus 6. 2 cubed is 8, which is less than 2x plus 6. Now we can take 6 from both sides, so 2 is greater than 2x. And if you divide by 2 on both sides, 1 is less than x. Or to make that easy to read, you need to say x is greater than 1. So that's our second inequality. Now, if we use that little coordinate plane again, just as a visual, x must be greater than negative 3, so it's everything going this way, and x has to be greater than 1. So here our intersection is at x equals 1, because anything greater than 1 is obviously also going to be greater than negative 3, but not everything greater than negative 3 is greater than 1. Because let's say you use the x value negative 2 or negative 1. Both of those are greater than negative 3, but they're not greater than 1. So really the only inequality that matters here is this x is greater than 1, because it technically includes both inequalities. Because anything greater than 1 is going to be greater than negative 3. Now, we also have the situation here, what would happen if this was less than instead? So I'm going to erase all of this just so it's easier to see. So this is just saying log base 2 of 2x plus 6 is less than 3. So we're still going to have that same inequality of x has to be greater than negative 3, because again, no matter what, whatever's inside the parentheses cannot be negative. So again, 2x plus 6 is greater than 0, 2x is greater than negative 6, x is greater than negative 3. Okay, but now 2 cubed is now going to be greater than 2x plus 6 rather than less than. So 8 is greater than 2x plus 6, 2 is greater than 2x, so 1 is greater than x rather than x being greater than 1. Okay, so that's our second inequality for this situation. If we draw that coordinate plane again, it's going to look a bit different now. So x has to be greater than negative 3, like we had last time. But now it has to be less than 1. So it's pointing opposite directions. So our inequality isn't going to be as simple. It would actually look like negative 3 is less than x, which is less than 1. Because now the only values that can work are any x values in this range right here, because that's where they intersect. Yeah, and if you want to write it instead of an inequality, it would be -3 to 1. That's your interval form. Okay, now the question here is, do exponentials have restrictions on their domains? And the answer to that is technically no, because there's not going to be any value that'll make it undefined at that point, because even if in this situation, if x was a negative number, it would just turn it into a fraction, because whenever you have a negative exponent, so let's say we have 3 to the power of -2, you're just going to put 3 in the denominator so that we can make that 2 positive. So it would be 1/3 squared, which is just 1/9. Okay? So right here, to solve this, we can do 3 to the power of x plus 2 is greater than, if we had 4 to both sides, it's greater than 27. So now to get x out of the exponent, we can just take log base 3 of 3x to the power of x plus 2. Sorry, 3 to the power of x plus 2. And do log base 3 of 27. Because now we're going to have x plus 2 is greater than 3. Because 3 to the power of 3 is 27. So x is greater than 1. And that is your answer. Very quick, very easy. Very demure. Okay. Now for this one, if we're finding the inverse, an easy way to do that is just swapping x and y, then solving for y. So here, instead of y equaling all of this, it'll be x equals 3 times 2 to the power of y plus 1 rather than x minus 4. And we're going to solve for y. So our last step here is taking away 4. So now we're going to add 4. X plus 4 equals 3 times 2 to the power of y plus 1. Then we're going to divide by 3 on both sides. So x plus 4 over 3 equals 2 to the power of y plus 1. And we're going to use the same trick we used on this one. We're going to take log base 2 of both sides. So log base 2 of x plus 4 over 3 is equal to y plus 1. So y equals log base 2 of x plus 4 over 3, all minus 1. And you can also write that as just the inverse, so f of x equals all of this. Okay, now for this one right here, we're just going to do the same trick where we swap the x and y's and then solve for y. So here, instead of y equaling all of that, it'll be x equals natural log of 2y plus 3 plus 10. So now we're going to solve for y, so we're going to take 10 from both sides. X minus 10 equals natural log of 2y plus 3. Then to get rid of this natural log, we're just going to put e to the power of whatever is up here. So e to the power of x minus 10 equals 2y plus 3. So we're going to take 3 from both sides. E to the power of x minus 10, all minus 3 equals 2y. Then divide both sides by 2. So y equals, or you can also just say inverse of g of x equals e to the power of x minus, e to the power of x minus 10 minus 3 all over 2. And that is your answer.
Okay, we're going to start with the first problem. Log 4 x is less than 3. And okay, so we're going to start by separating numbers from the log. So we're going to do x is less than 4 to the power of 3, because the base of 4 to the power of 3 is the same thing as x. So when you're thinking about it, you can do log a x is less than b, and a to the power of b is the same thing as x. So from there, you're just going to multiply 4 times 4 times 4, 4 to the power of 3, and that will get you x is less than 64. So 0 is less than x is less than 64, or you can write it in the parentheses like this, 0, comma 64. All right, next one we're going to do is 2. So that's 2 to the power of x plus 3, and then plus 5 is greater than 37. So we're going to treat this just like a regular equation, and we're going to subtract 5 from both sides. So it'll be 2x plus 3 is greater than 32. And then we're going to bring a log on both sides, so we'll be able to get rid of the 2. So we'll do log 2, and then 2x plus 3 is greater than log 2, 32. And this will cross out these 2's. Great. And then we'll be able to use the top parts, so the x plus 3 and 32. And log 2 to 32 is just 5. Because 2 times 2 times 2 times 2 times 2 is just 32. So that's 5. And then that'll make it so when you subtract 3 from both sides, its x is greater than 2. Or, if you want to do parentheses again, we'll do 2, comma, infinity. Alrighty, I'm going to skip down a couple problems because these are generally the same idea. So we're going to do number 6, which is ln x plus 4 is less than or equal to ln x minus 6 plus ln 3. So we're going to start by combining the ln's on the second side. So we're going to do ln, excuse my handwriting, x plus 4 is less than or equal to ln 3, excuse me, 3, and then we're going to do x plus 6, so that we can just combine those two to make it easier. And then from there, because both sides just have one ln, we can just do x plus 4, and then that is less than or equal to ln, sorry, disregard that, 3, x plus 6, and then you're going to bring over the 3 to both the x and the 6, so it'll just be x plus 4 is less than or equal to 3x minus 18, and then you can bring the x's to the same side and the plain numbers to the same side, so that would get you 22 is less than or equal to 2x, and then when you divide both sides by 2, that gets you 11 is less than or equal to x. Perfect. And then if you want to go ahead and write that in a different format, you can do x is greater than or equal to 11, or in brackets, because it includes, because it has the also equal to part, in brackets 11 to infinity. Perfect. Next, we're going to go to 7. This one is ln x minus 4 plus 8. So for this one, we're going to start with making this just an x, and then we're going to do ln, we're going to switch the y and the x, so we can more easily do this, y minus 4 plus 8, and then we're going to add an e to both sides so that it'll get rid of the ln, so that'll be e to the power of x, and we already subtracted 8 from both sides in this instance, so we're going to do e to the power of x minus 8 equals e to the power of ln and then y minus 4. And then from there, that'll get rid of this one. So it'll just be e to the power of x minus 8 equals y minus 4. So when you're finding the inverse, you're just going to do the g and then a negative 1, x in parentheses, don't forget that part, equals y. So those are the same thing. And then when you bring the 4 to the other side, that'll get you the final answer of e to the power of x minus 8 plus 4. Alright, and then our last one that we're going to do is 10. So that is 2e to the power of x plus 8 minus 5. So we're going to start with swapping the x and the y again. So we're going to do x equals 2e to the power of y plus 8 minus 5. And then we're going to bring the 5 to the other side. So we're going to do x plus 5 equals 2e to the power of y plus 8. From there, divide the 2. Just simple stuff. X plus 5 over 2 equals e to the power of y plus 8. And then, to get rid of the e, we're going to do ln, inverse processes. And we're going to do ln x plus 5. Sorry, it's going to go a little squished from here on out. Over 2 equals, that is what you're doing originally, and then they cross out. So it'll just be y plus 8. And then your final answer will be y equals ln times x plus 5 over 2. And when you bring the 8 to the other side, that'll get you negative 8. There we go. Hope that was helpful.
Hey guys, it's Rena, and today we're going to be doing lesson 2.14, and today's special guest is...
Hi guys, I'm Sunny, and I'm in pre-calc right now, and I'm ready to help.
That's good.
Okay, so let's look at this, guys. So we have Mr. Bean, and let's see what it says. So Mr. Bean started learning Chinese in hopes of translating all his videos one year. He created some data to find a model for the number of days studying as a function of the number of words he learned that day. So we have this list, and what we're going to do is I already did it for time's sake, but we're going to try and we're going to plug it into our calculator. And let's see if I can get it. I have it right here, but I used the calculator and I plugged all of the values in. And then what I can do from there is I can go to calculator, and I can go to statistics, and then stat calculations. And since we're doing a logarithmic regression, so we can press logarithmic regression from there, which is actually B. So we can press that, and we can load that list into our logarithmic regression. So we can do the x, so we can take the x, and then we can take the x and then the y as well. Once we get that in, it'll give us some numbers. So what do these numbers mean? So the base form of the logarithmic regression is going to be like a plus b times ln of x. That's what we need. And the values, when we plug everything in, we get the values for the logarithmic regression. So if you're doing it right, you should have, for a, you should have 9.03031 plus 4.350. Remember the 3 decimals, ln of x. Right? So that's what it should look like, equals f of x. So now what we do is we have this whole equation. So what we can do is we have 1,000 words. How many days would it take for Mr. Bean to learn 1,000 words? What would we do? All we have to do is plug in 1,000 for x. So let's do that on our calculators. And if we did that on our calculators, that would be about 21 days. So, but let's see. So now it's asking us to solve for y. I mean, we can put y and we have to solve for x now. So let's see. So he studied for 60 days. Let's see what we can do. So now we know f of x is actually 60. So everything else is the same. 31 plus 4.350 ln of x equals 60, because that's where we get 60 from. So now we can solve for x. First, what we have to do, add 9.31, and then we would get 69. I'm moving this over here. 69.031 equals 4.335 ln of x. So now what we can do is we can divide by 4.35. Erase some of this. So now what we can do is divide, and we can get 15.869 equals ln of x. So what we can do now, all we have to get rid of is this ln, right? What we can do is we can put to the power of e to both sides. So this cancels out the ln, and then we get x equals 15.869 to the power of e. And if we do that on our calculator, we can get 7,96577 words. That's x right there.